In this video, I'll show you how to work with a differential equation. In the last video, we came up with a differential equation to model the scenario where you're cycling fresh water into an overly chlorinated pool. You start out with 100 milliliters of chlorine, and you want to get it down to 3 parts per million, or 3/4 of the current level, which would correspond to 75 milliliters. How do you tackle this? Well, start by making a table. I'll start by using hour-long intervals to get a rough estimate of things. So, first we know that at time 0, the amount of chlorine in the pool is 100 milliliters. And based on this, we can compute the rate of change of chlorine at time 0 using the formula. So we'd get negative 4.04 milliliters per minute. If we assume that this rate stays constant for the next 60 minutes, then we'd be losing 0.04 milliliters per minute for the entire 60 minutes. So we'd do 100 milliliters, our starting value, minus 60 minutes times 0.04 milliliters per minute. This would mean we're losing 2.4 milliliters, leaving us with 97.6 milliliters at the end of the first hour. And now at the end of the hour, the rate of change would change again. And we could use our formula to find this new rate of change, which would be negative 0.03904 milliliters per minute. If we assume that this rate stays constant for the next hour, then we would lose 60 times 0.03904 milliliters, bringing us down to 95.2576 milliliters of chlorine left in the pool. And we could continue this process. So, after 4 hours, we'd be down to almost 90 milliliters of chlorine left in the pool. We'd get to 75 milliliters eventually, but it looks like it would take a pretty long time. Of course, these numbers are bad approximations. The big assumption we made was that the rate of change stayed constant for an entire hour, but this isn't the case. We're constantly cycling chlorinated water out of the pool, which means the amount of chlorine in the pool is constantly decreasing, which means that the rate of change of chlorine with respect to time is also constantly changing. So how could we make better approximations? Well, one thing we could do was use 1-minute increments. And we could go through and fill out the table and we would get a lot of numbers. And now, keep in mind that in our initial estimate, it was going to take way more than 4 hours to get down to the appropriate level. So in these 4 minutes, we're only getting down to about 99.8 milliliters of chlorine in the pool. It would take a lot of steps, but you could set up a spreadsheet to do all the heavy lifting for you, and eventually you'd be able to figure out when we would get down to 75 milliliters of chlorine in the pool. And of course, you could be even more accurate than doing it by the minute. You could do it by the half minute or even by the second. And you just got to use your spreadsheet to do that heavy lifting for you.